We have the circles practice test video. In this video, we're going to review all of the topics necessary for the circles test. And on the practice test, I made it a little longer than I would have done an actual test. So I hope you guys understand there won't be this many problems on this test, all right? So the first thing we should understand is what is an arc, okay? And I was talking to my class about that today. There's a difference between line segment IF and arc IF, okay? We read these different, right? So arc IF is this part of the circle that's on the actual edge, right? Whereas line segment IF would be what I get if I connect them with a straight line, okay? So they're totally different. So we got to understand what we're talking about here, right? So if you don't know what an arc is, if you haven't seen that symbol, you might be in the wrong place, and you might need to go back to watch that little 9-minute video on central angles and arcs. All right, and in that video, we define the measure of an arc, okay, as the measure of its central angle. Okay, so the central angle of this arc that I'm highlighting in blue, all right, the central angle of this arc is 85 degrees. And when I look at this other arc that I just highlighted in red, okay, the measure of this arc would then be 60 degrees. So one thing that we got to see is that if I take those two and add them up, all right, it's hard to tell on YouTube how loud the students in the background will be, but excuse me if it's distracting to you guys on YouTube trying to raise your grades. All right, so 60 plus 85, all right, we add those two up, and we're going to get 145. Okay, so that's all we have to do to solve this problem. So again, this takes us back to the definition of arc. So that's all these problems are. We're just learning what an arc is. Okay? In this case, we have an angle, RPS. All right, so what I've been telling you guys to do is always go like underline what we're looking at, make sure you're reading it, and try to force your brain to do anything but freeze. All right, the last thing you want to do in a math is just kind of sit there and waste time. Okay, we have RPS. So in this case, for this problem, what we want to observe is that one of the things that we need to use is this idea of a diameter. And that's why the worksheet told us that if they look like diameters, then they are diameters. All right. A diameter is a line that goes straight through the center of a circle. And because half a circle is 180, we should all realize that this whole arc must be equal to 180 degrees. And because that must be equal to 180, I know that 50 plus 67 plus whatever this x is right here, those should all add to 180. So that's one way you could do the problem. Okay, you could solve it like this, and you could just take things away from both sides like how you would do any algebra. Right? Let's take 50 from both sides, fine. Okay, and then you get x plus 67 equals 130. Okay, and then if I take 67 from both sides, so we take 67 from both sides, and we get 63. Okay, so we solve our problem. Okay, 63 must be right here. Okay, that's that angle right there, that piece. So again, the arcs and the angles are helping us try to understand all the different parts of a circle, the way we measure them. All right, so if we go to number 3, we can take a look at HF and see that this is an arc. So in that case, I'm talking about the part on the circle. Okay, and again, because this inside angle is 57, and because that's a central angle, right, the vertex at the center, that means this also must be 57. Okay, so again, I want to emphasize that this is only true because this is the central angle. Okay, the fact that this point in the middle is the center. Okay, that's what makes this true. So that means HF must then be 45 plus 57. Okay, so we add that there, and we'll get 102. All right, so that's for number 3. Now, let's take a look at number 4. If I was you, I'd probably pause the video right now and try to solve this one on my own. And here we are. All right? So like I was telling you, the first thing you might want to do is actually always go look at the arc we're actually trying to get. So let's put this one in red. Okay, I'm going to start at T, and then I have to go to U, and then R. And so we're trying to get this whole arc, the whole red thing. So we want to try to think of any kind of way to basically get all of that. What would be the fastest way? All right, there's more than one way to do this problem. Right, there's lots of things we can see. We might even remember, hey, look, we got vertical angles right here with these two lines, right? So if this is 55, then this piece is 55, right? We got vertical angles, yeah? So one thing that we should be able to see, though, is that this line right here cuts this circle in half, okay? So it might not always be obvious where to start, but we should be able to see that half of a circle is 180. So from here to here, the arc RU is equal to 180 degrees. But if I want to get this whole arc TUR, well, because this central angle is 55, that means this arc TU is also 55. And therefore, if I want to get TUR, I'm going to have to add up first this part of TU, that's 55, and then I have to add up the other 180 degrees to finish. So this is going to end up being 55 plus 180, okay? And if you add those two up, you're going to get 235. Okay, so again, that's for number 4. So if you need more work on that, again, I would recommend you go watch the video on arcs and angles, all right? The definitions are really important, and you'll definitely be very confused if you're not sure how to measure them in the first place. All right, for number 5, I have a whole video that I did on these problems, all right? So I'll do one example right now to make sure we got the process. For this one, it says the length of the arc. So we would want to use the arc length formula, okay? And by using the arc length formula, get x over 360, and then we have 2 pi r on this side. Okay, so we could go put in all of our numbers, all right? Where do our values go? Okay, the value that goes here with the x is going to be this angle over here, all right? Okay, and for the radius, we will plug in 9, okay? So we should understand the radius of a circle is the distance from the center to the edge, and that's something that has to be given to you in a case like this when we're solving the arc length, right? So we need to understand that, you know, when we do things with the Greek letters and the variables, there's like a certain order to the way we write things, okay? Think about it. We don't write pi 2, okay? We can write pi times 2, but we don't really write pi 2, okay? We would usually write 2 and pi. Okay, so usually we put, again, think about it. Which one of these looks more familiar? Do we write x2 or 2x, right? This looks totally strange. We don't write x2. We write 2x, right? And so there's some things that are customary in math, right? It's also customary to put a Greek letter in front of a variable, okay? Because it's kind of like a coefficient. So I hope you can understand why we have these things in this order. We did the number, then the Greek letter, and then the variable. The second we get to this step, this is where I start losing people. Because before we even go break down this fraction, okay, and we got to realize that the top is 45 times 1, and the bottom is 45 times what? Okay, 45 times 8, right? So I could cancel the 45s and get 1 over 8. But what's going to happen over here is now we have 18 pi. And I've noticed a lot of my students kind of, you know, can get a little confused as to what happened. Why is the 9 over here, and what order do I have to do these in? It never matters what order we do multiplication in. So we need to realize, even though we wrote it like that, it doesn't mean we have to calculate it like that, right? So this would be the same thing as 45 over 360 times 2 times 9 times pi. Okay, and so that's where the 18 came from. 2 times 9 is 18, okay? I think this extra step is a little extra, and I don't think you necessarily have to do that. We should just do 2 times 9 and write 18. So in the case that confuses you, I'm talking about that here. All right? All right, so over here, we got 1 over 8 times 18 pi. So what you guys got to realize is that to multiply by 1 over 8 just means to divide by 8, okay? So again, multiplying a number times a fraction just means do the number times the top. So I got to do 18 pi times 1, and that's just 18 pi. All right, so what does it mean to divide by 8? Okay, one way to look about it is that it means to divide by 2 3 times, because 8 is 2 times 2 times 2, right? But if I take a look at this actual calculation, we only have 2 times 9 pi. So that means I could cancel out the 2's, but then over here, I'm going to have 9 pi over 4. Alright, so this would be our final answer. The only thing that's missing would be yards, okay? And just yards, not yards squared, again, because this is length, okay? So I want you guys to realize this formula would tell us how long a string would be if it was around the whole circle, alright? But the arc length is telling us how long would only this little piece be, alright, that covers this little angle of 45 degrees of the circle. Alright, that would be about 1/8 of the circle. It would be exactly 1/8 of the circle. That's what this is showing us, alright? So rather than focus on the calculation, in this example here, what I tried to focus on was the thought process, alright? We'll need the same thing in the next problem, alright? For number 6, so arc length. The formula looks very similar, again, because it's giving us what part of the circle do we want. Sorry, I did number 6. I didn't want to do that. All right, what I'm going to do instead this time is just give you guys the answer for number 6. So you guys should calculate this on your own, please do. Try it, pause the video, and I'll show you the answer up here at the end. All right, you should have got 5 pi over 2 for this problem. All right, for number 7, we're doing area this time. And so I wanted to do one example of each so this video doesn't go too far over. It'd be nice if this could be less than a half hour. Alright, so sector area, like I was trying to do a previous one, the same thing, okay? The x degrees over the 360. Again, the x symbolizes our central angle, okay? So that's what we mean by x, okay? So the x is our central angle, and then here we got pi times the radius squared. Alright, so in this case, we just go plug in our values. What's the value of our central angle? Well, the central angle is 45 degrees. So we'll put that there. Now I only have to plug in one value for the radius, which is 10, and then I have to square that, and that'll make 100. So, as we saw previously, right, 45 over 360 is 1/8, okay? And then 10 squared makes 100. So we're not going to write pi 100, but we write 100 pi because this is just the custom in mathematics, all right? It's going to look funny if we don't. All right, and then like I told you, this is just dividing by 8. So we got 100 pi divided by 8. Well, I tried to mention to you that this is the same thing as dividing by 2 3 times, right? And so we know that 100 is 4 quarters, right? 4 times 25. And 4 is 2 times 2. So that means 2 times 2 times 25 is 100. Now all we need is the pi. And that tells me I can cancel one pair of 2's, right? I can cancel another pair of 2's. So what's going to be left over is 25 pi over 2. That's our final answer. Okay, and then this time, these units are in yards squared, okay, square yards, because we want to keep some kind of sense of what sector area is. And again, if you're not sure what sector area means, okay, you should probably go back and watch the video specifically on that if this topic is giving you trouble. But otherwise, I'm going to move on to the next topic, okay? Again, I will release the answer for this one. So number 8, go ahead, pause the video. Please pause it and do this calculation on your own. And the answer for number 8 would be 25 pi over 4. Alright? Alright, come on, I'm sorry. It's like he's practicing for High School Musical Part 8 or something. Alright, here we go. Number 9. So, we're looking at inscribed angles now, okay? So we want to notice the difference between what we were just doing. Our central angles and inscribed are totally different. So let's understand the difference, all right? Well, a central angle has a vertex at the center. All right, so that's our definition of arc measure, is that if that's 30 degrees, then the arc it intercepts is 30 degrees, okay? And again, that all assumes that that point is the most special point in the circle called the center. All right? All right, if we have an inscribed angle, though, it's totally different. Okay? If this is 30, then the arc that it makes is 60. It's going to be double, okay? So to do these problems, we're looking at a one-step example here. Okay? You guys should be able to see visually the connection between this arc that's 94 and this angle over here. You guys need to realize, okay, this angle that we need to find, that I just put an X in, this angle intercepts the arc of 94. And so the theorem that we have, if I want to write this in symbols, would be that the measure of HG is equal to double the measure of angle GFH. All right, well, HG we have a value for, right? HG is 94. Okay? And over here, we got double the measure. Oh, my bad. I did that backwards. All right. All right, cool. So, what we had here was 94. Okay? That was correct. Okay? I had the right thing here. What was happening now is that when I do double the measure of GFH, what I want this to say now, all right, I'm trying to find the measure of this angle. I'm trying to find the measure of GFH. So what I want to do is not have 2. I don't want double the measure of GFH. I just want GFH. So that means I have to divide both sides by 2. This would be an example of what I've been explaining to my students as inside is half, okay? The GFH is the inside angle. You can see it graphically when you look at the picture. All right, GFH is that X inside. All right, so I have to take half of 94. All right, and what's half of 94? All right, you get 47. All right, so we have 47 degrees for X. Okay, so again, this is the inside is half, outside is double relationship. All right, this goes back to the definition of an inscribed angle. Okay. This relationship is only true when the vertex of the angle is directly on the circle, okay? If the vertex of an angle is directly on the circle, then the arc that it intercepts, okay, will be double the measure of the angle itself. Now we go take a look at number 10, and I'm guessing this is not a one-step problem, right? This is a little more complicated, all right? But I think you guys are going to start to get an instinct for what's happening in these situations. If we look at this 128 degree angle, okay, we're going to darken that and see that it touches in those 2 places. All right, and then now, this whole arc, SRQ, all right, arc SRQ has to be double of 128, okay? So 2 times 128 is going to be this whole arc, okay? And I'm going to use these little marks to show that we're getting the whole thing. Okay, so 2 times 128 is 256. Alright? And at this step, we finally get to a multi-step problem so that I could review the list of steps again. Okay? So we talked about for inscribed angles, all right. There was a list of 4 things that I gave you, and then at the end, the 5th step was kind of special. All right. This list of things that we're saying is overly simple. All right. I oversimplified it, but I think it's simple enough to where we can remember it and use it to help us, okay? So let's make sure that you have this before you guys walk into the test, okay? I could like almost guarantee that if you don't know anything about inscribed angles, it's probably going to be below a C on this test. All right? So what you need to know, we say inside is half and outside is double. Okay, that is enough to help us remember what we need to solve these problems numerically. But we also need to know a whole circle is 360 and a half a circle is 180. And those are things that we've been working with for a while. All right, the fifth step here is a very special step, and the step is think. Okay? You have to be creative, you have to make realizations, and you have to try to use some deductive reasoning. Okay? So, just be clever. This angle right here, this piece of the arc. Thank you for controlling your uncontrollable singing, man. All right? So, we got 104. Okay, how did I know that that piece had to be 104? Well, it's because I knew to jump to this one. Okay, I knew that I had no choice but to use the whole circle was 360. Okay, we couldn't do an outside as double because we had already done that, right? We already got this number. Okay, so you end up doing a multi-step problem. Our first number that we got was this one, right? First, we had to find that. Then, I had to find this number, right? That was the second step. The third step is now going to be for us to observe that the blue arc that we just found out is intercepted by the angle that we need. So that coincidence means that if I write inside as half, like that step, then I'll be done. And this will be 52 degrees. All right? So we move on to the next one. All right, we'll take a look at number 11. So, in this case, where would we start? Do we start with the inside is half? Okay. We can't start with the inside is half because we only have an inside number. Okay, so since I have an inside number, I'm going to darken the lines. Okay. I'd like you to realize how simple and how helpful that is to just go do that. Now we know from here to here has to be double of 96, right? 2 times 96 makes 192. And so we have that right there. Now we have to get these this piece of the arc, but now we should realize all the colors we have, right? The red, the blue, the yellow, they make the whole circle. So together, they should all add up to 180, right? X plus 192, not 180, sorry. All right, they should all add up to 360, because that makes a whole circle. Okay, so if you go through, you could easily solve this problem by just doing subtraction. Okay, so I don't want to take away that opportunity from you, but just subtract those two numbers from 360, and you'll be able to tell what X would be. Okay? So that was kind of like a two-step problem in a way. All right, number 12 here. All right, in this case, we could say, can I do it inside as half? Well, it looks like we can, because I have an outside number. So I'm going to go trace that back to an angle and see what it intercepts. All right, and we see that we got this angle of KML. All right, KML intercepts that 66-degree angle. So this must be 66-degree arc. And so the angle inside, the inscribed angle, again, because that's right there on the circle, we could take half. Okay? And now, you actually don't want to forget something that we learned in the first semester, right? The three angles in any triangle have to add up to 180. And so, we know what we could do, okay? If we put an X right here, we know that X plus 69 plus 33 must equal to 180 because we have a whole triangle right there, okay? So, think about what happened on this problem, right? We got the first step, we said inside is half, all right? That was good, okay? But the next thing we did was think, okay? After we did outside is half, we had to think for a second. And we realized, wait a minute. As we were thinking, we noticed that we saw a triangle and then realized that the three angles in any triangle have to add up to 180. And so in other words, if you know two angles in a triangle, you can find the third angle by doing addition or subtraction. Is the bell about to ring on me? Yeah. All right, you guys heard it. We'll pause the video for a second. So for number 17, you would want to darken the arc that we want to find. We want to find this arc BC. And what you want to notice is that this angle BCD, so when I darken this angle, we know that this blue angle is inscribed. And the reason why I know it's inscribed is because the vertex is right on the circle. All right? So that means the angle that it intercepts, all right, has to be double of the inside according to that theorem. So outside would be 140 degrees. All right? That's what that would be. So that's a one-step problem. Okay? So just please understand that the word tangent is what we're getting tested on in this section. Okay? And then in some cases, the tangent lines make an inscribed angle. That's pretty simple. All right? We'll move on to the next one. All right, so for 18, this is really similar to the problem I did on 16. So I would invite you to pause the video, go back and look at 16 if you need to, but anything but just writing the answer, okay? Try to solve this one on your own before you do it right now. And I really hope that you actually tried it, okay? Because there will certainly be a problem like this on the test. This is one promise I will make you, all right? One of these will be there, all right? And I need you guys to know that this is 90, and that's 90, okay? And then now we need to know, what do these two angles have to add up to? All right? All right. So what do I know about these two? All right. What do these two have to add up to? All right. Well, if I look at the whole equation, we could write this every time. I just think it would be a little naive to just write that every time and not realize that there's a bigger pattern. Okay. We know that those have to all add up to 360, and that's one way to do it. Okay. But we also notice that since these will always add up to 180, right? If I just subtract 180 from both sides, well, 360 minus 180 is 180. So I think a faster way to do the problem would be to realize that x and 55, right? These two angles have to be supplementary, okay? And so we just have to realize what has to go on the other side is 125, okay? Now, one thing I'm trying to cover here is that some of you guys might have been completely lost still, even that that's 125. What does this arc have to be? Okay? But by definition of arc measure, all right, they're the same. So our arc is 125 then. Okay? So again, don't forget that the tangent will always make a right angle when we connect that with the radius. Okay? The tangent line and the radius always make a right angle. So 19 is very similar to the last one. I'll go ahead and, I won't do this problem, but instead I'll just put the answer up. So, like I said, please pause the video and then actually solve this one on your own. All right? And if you get that, some of you guys might be saying, wait a minute, don't those two have to be supplementary? All right, and they do, right? 118 and 62 make 180. So once you really notice the pattern, you probably won't have to think that hard. All right, but you got to put in a little bit of studying ahead of time. All right, so for number 20, we should see again, right? We have these two angles are going to be the ones across from each other, and so they should be supplementary. So in this case, we should have 70. All right, so now for 21, we're going to talk about how to get the equation of a circle, and this will be the end of the review for the test. All right, this video is just over a half hour long. So first we're going to write the general equation of a circle. That's what we call this, okay? But this is a circle with a center at the point H and K and a radius of 5. So the 5 would be our R, okay? That's the radius. So if we just substitute all these values in here, we want to make sure that we don't mess that up. So I want to have x minus 2 squared plus y minus negative 7 squared. Okay, and this is why I tell you guys that we change the sign, okay? Because who wants to write minus negative 7, right? Notice that the the positive 2 right here ends up looking like a negative 2, because that's what it means to subtract a positive 2, right? If I subtract positive 2, then I'm doing minus 2. All right? But subtract a negative 7 actually means to add. Okay? So that's why we changed the sign of that one to a positive. All right? Then the radius should not just be 5, but it should be 5 squared. And so rather than just writing 5 squared, we probably see the value of 5 squared, which is 5 times 5 is 25. All right, so that's the way we do these kind of problems. Okay, I would highly recommend that whenever you're doing these, just write the equation and then look at it, make sure you got everything right, and then just drop in the numbers afterward. Okay? So we'll go to 22 the same way. So in this case, we got a more complex radius, so I guess that gives us something else to talk about. All right, maybe I should put one of those like that on the test, huh? All right, then over here we got x minus h squared plus y minus k squared equals the radius squared. Okay, and like I said, we just plug in our values. All right. What I like to tell students to do is just put all the parentheses and everything first, and then just get ready to go plug in your values. All right, so the h is this value, okay? And as I told you guys, we end up having the opposite signs inside the parentheses. So the negative 9 will become a positive 9, and the positive 1 will become a negative 1, okay? But now I have to square 4 root 2. And this is why usually when we're doing problems, I try to tell you guys to always put parentheses before you substitute, because we now have to multiply both of those. All right, so when we do this calculation, the left-hand side isn't going to change at all. All right, but the right-hand side is going to change a lot. All right, because now to square 4 root 2 means that we have to do 4 root 2 times 4 root 2. All right, that's one way to look at it. Okay, another way to look at this would be to square each of them. All right, so I'm just going to go ahead and do it this way. All right, 4 times 4 is 16. And root 2 times root 2 is 2. So I might have already confused a couple people, right? One thing that we could do is rearrange these values. Yeah? We could see that this is 4 times 4 times root 2 times root 2. Okay, and then you guys got to know, okay, 4 times 4 is 16, and root 2 times root 2 is 2. So I'm hoping you guys can see how I got what just happened. All right? But what's 16 times 2? 32, right? So on the left-hand side, we have the same thing that never changed at all. All right, but we did have to kind of simplify because we had a more complex radius, right? We had 4 root 2. All right, so in this case, we would get x plus 9 plus y minus 1 squared equals 32. And that would be like our final answer, I guess. All right. That's 32. All right, so now we do 23, 24. So I would invite you to pause the video and do this one on your own. And I'm going to show the answer, so pause it so you do it on your own. All right, learn something. All right. We should have got, again, look, the negative 7 turns into the positive 7 turns into a negative, and the negative 8 turns into a positive 8. Okay, and over there, the radius isn't just 10, but it's going to be 10 times 10, which gives us 100. All right, for number 24. All right, pause this and see if you guys could do this on your own. All right, if you're in here right now thinking about it, I'll wait an extra beat so you guys could think about it. All right, and I'm hoping that you paused it and you got x plus 4 squared plus y plus 6 squared equals 64, right? Because we got to do 8 times 8. So this will be the circle review video. All right, 35 minutes about. Good luck. All right, studying for the test on Friday.